Dear student, Assalamu alaikum. I am Ali Raza from Maryland High School, and today we are going to start a new chapter, and that is dynamics. Student, dynamics is a branch of mechanics in which we study about motion and causes of motion. In our previous chapter, that is kinematics. In kinematics, we discuss about motion without causes of motion. But here, whenever we studied about a new chapter, in this chapter, we studied about motion and also its causes of motion. Student, in this chapter, we discuss about force, inertia, momentum, the Newton laws, acceleration and tension in a string, centripetal force, centrifugal force, law of conservation of momentum, friction, rolling friction, and methods of reducing friction. These are some topics that we study in this chapter, that is dynamics. To understand about the causes of motion, Newton's laws are fundamental. But before studied about the Newton's laws, we have to study first of all about force, inertia, and momentum. Student, now we discuss about first of all about the force. What is force? First of all, student, you can say that if a body in a motion or in a moving state, after millions of years, it will be moving if no external force act on it. Just like first of all, you can say that if a body in a motion state, after millions of years, it will be moving if no external force act on it. Just like student, you can say that if we have a ball and if we throw a ball is moving. And after millions of years, it will be moving if no external force act on it. Similarly, the next thing other is that if a ball or if anything, just like you can say that if we have a book and that book, if in a rest state, after millions of years, if no external force act on it, the book will be in a rest state. Two things you should have to first of all understand that if a body in a moving state, after millions of years, it will be moving if no external force act on it. And next thing is that if any body in a rest state, after millions of years, it will be in a rest state if no external force act on it. The next thing is that student, whenever we apply a force on any object or any body, the direction of that body is also a change. Just like student, you can say that whenever a batsman hit the ball goes in any direction. So you can say that actually batsman apply a force on the ball. That is why the ball change its direction. So it means that whenever we apply a force on anybody, the direction of that body is the change. That is the direction. Next thing, student, you should know that whenever we apply a force on any body, the shape of that body can also be changed. Just like student, whenever we cut an apple from its sharp edge of knife, the shape of an apple totally change. So the student should know that whenever we apply a force on the body, its state, we can change its state, its direction can also change and its shape can also be changed. Now the student, we first of all again discuss about the four things we discuss about. First thing is that if we not apply on just like student, if a body in a motion or in a moving state, after millions of years, it will be moving if no external force act on it. Next thing is that if a body in a rest state, just like here we have a book and after millions of years, it will be in a rest state if no external force act on it. The other thing is that whenever we apply a force on any body, the direction of that body can also be changed, and whenever we apply a force on a body, the shape of the body can also be changed. Just like student, you can say that whenever we cut apple from the sharp edge of a knife. Now we should have to know about the basic definition of the force. So what is a force? Hope so you understand that. A force is moved, tends to move, stop or tends to stop the motion of a body. And the next thing is that whenever you apply a force on the body, the direction of the body can also be changed. That is the basic definition of the force. The next thing is that the force is a vector quantity. You should know that what is the which quantity force? Force is a vector quantity, and this you should also know that the SI unit of a force is the Newton. And the symbol of the force is F. Now the student, these are the some points that we discussed about this force. Just like first of all we say that if a body in a moving state after millions of years it will be moving if no external force act on it. And if a body in a rest state after millions of years its state can never be changed if no external force act on it. So the other thing is that whenever you apply a force, the next thing is that whenever you apply a force on any body, the direction of that body can also be changed. I give you example, just like student, you can say that whenever a batsman hit the ball, the direction of the ball can also be changed. On the other hand, whenever we cut an apple from the sharp edge of a knife, the shape of the apple can also be changed. Actually, we apply a force on the apple. If we discuss about the basic definition, hopes you understand that a force is moved, tends to move, stop or tends to stop the motion of a body, and whenever you apply a force, the direction of the body can also be changed. The SI unit of a force is Newton. Force is the vector quantity because it has a direction, and the last thing is that the symbol of the force is F. Now the student, we comes to the second quantity that we discussed about, that is inertia. Student, Galileo was a scientist. He observed that it is easy to move lighter object as compared to heavier object. Why he says that? Just like student, you can say that if we have a tennis ball and that tennis ball in our rest state, and if we want to change the state of that tennis ball, we need less force because tennis ball has less mass. On the other hand, if we have a football and we want to change its state from rest to motion, we need greater force because football have greater mass. So Galileo says that it is easy to move lighter objects. So it means it is easy to move tennis ball as compared to football because we need less force because tennis ball have a small mass. So from this point of view, Newton conclude that whenever we change the state of a body, again student, whenever we change the state of a body, that body resists in its change. What? That body resists in its change. That resist actually is called inertia. Again student, Newton says that whenever we change the state of a body from its rest to motion or motion to rest, that body resists in its change. Actually, that resist is called inertia. Inertia is also a property of a matter. If we talk about the basic definition of the inertia, inertia is that inertia of a body is its property due to which it resists any change in its state of rest or motion. Just like student, I give you example. If we have a desk here, and that desk in a rest state. So whenever we change its state from rest to motion, this desk resists in its change. It means this desk first of all does not want to move. It resists in its change. That resist actually is called inertia. So the last thing here you should have to understand is that the inertia is depend upon the mass of the body. Just like if a body mass is small, then its inertia is also a small. Just like here I have a ball point, the mass of this ball point is a very less. So whenever I change its state from rest to motion, actually it resists, but its inertia is very small because its mass is small. On the other hand, if I change the state of desk from rest to motion, that desk also resists in its change. Why? Because that desk also resists in its change. So the student desk has a greater mass, That's why desk has greater inertia. If a body mass is small, its inertia is also small, and if a body mass is greater, its inertia is also greater. So that is actually the inertia. What is inertia? That whenever it resists in its change, any object whenever we change its state. So the last thing we should have, the last thing we discuss about the momentum. Student, in inertia, I say that to you, if a body mass is small, its inertia is also very small. But whenever the mass of a bullet is very small, you should know that the mass of a bullet is very small, but whenever we fired this bullet from a gun, it's too much effective. Almost it's impossible to stop it. So you can say that its inertia will be greater. So why? In our previous topic, we say that if a body mass is small, so its inertia is also very small. Student, we says that in inertia, if a body mass is small, its inertia, if a body mass is small, its inertia is also very small. But whenever a bullet fire from a gun, its inertia will be very greater. It means you can say that it's too much effective. Why? Because to completely know about inertia, we does not need only one quantity. We does not need to know about only mass. We need another quantity to completely know about that the inertia, and that is the velocity. Again, student, to completely understand about the inertia, we have to know that another quantity with mass, and that is the velocity. So here is the product of mass and velocity, that is actually the momentum. Momentum is the product of mass and velocity. So the SI unit of the momentum here is the mass is kilogram, velocity is meter per second. So its SI unit is the kilogram meter per second is the SI unit of momentum. Momentum have also direction. That's why momentum is a vector quantity. So again, student, we discussed about here in momentum. I says that in our previous topic we say that if a body mass is small, its inertia is also very small. But whenever a bullet, you know that bullet mass is very small, its inertia should also be very small. But whenever this bullet fired from a gun, it's too much effective. Why? Because to completely know about the inertia, we should have to know another quantity with mass, and that is the velocity. So here product of mass and velocity actually is the momentum. Kilogram meter per second is the SI unit of the momentum, and here velocity used, that is why the vector quantity momentum is a vector quantity. Student, today we discuss about the basically force, inertia and momentum. First of all, we discuss about the force. In force, we says that if a body in a moving state after millions of years, if it will be moving if no external force act on it. Just like student, I say that if a ball is moving after millions of years, it will be moving if no external force act on it. Next thing is that if anybody in a rest state, it will be in rest state after millions of years if no external force act on it. Just like I says that if a book in a rest state, if no external force act on it, it will be remain in a rest state. The next thing we discuss about whenever we apply a force on any body, the direction of that body can also be changed. Just like whenever a batsman hit the ball goes in any direction. So you can say that actually batsman apply a force on the body, the direction of the ball can also be changed. So whenever again is the next thing is that whenever we apply a force on any body, the shape of that body can also be changed. Just like student, we cut an apple from sharp edge of the knife, the shape of the apple completely changed. So actually we apply a force through the knife onto the apple, that's why its shape totally changed. So if we discuss about the basic definition of force, so force is move, tends to move, stop, or tends to stop the motion of a body. So whenever you apply a force on the body's direction can also be changed. Force is a vector quantity because it has have a direction. SI unit of a force is Newton, and the symbol of the force is F. Now, the next thing we discuss about here, inertia. In inertia, first of all, we says that Galileo was a scientist, he says that it is easy to move lighter object as compared to heavier object, because for lighter object we need less force to change its state. For example, for example, just like student, you can say that if we have a tennis ball and that tennis ball in a motion state, and if we want to change the state of that tennis ball, we need less force to change its state. On the other hand, if we have a football, we need greater force because football have a greater mass. So you can say that for moving a lighter object is easy as compared to heavier object because lighter object have a small mass. So from this point of view, Newton conclude that if we change the state of an object, whenever you change the state of object, that object resists in its change. That resist actually is called inertia. Inertia is a property of matter. If any body's mass is greater, that inertia is also very greater. Just like if a tennis ball, the inertia of a tennis ball is less as compared to the football because the mass of the football is greater. That is basically, student, the inertia. The next thing we will discuss about today, that is momentum. Student, we says that in inertia, if a body mass is small, its inertia is also very small. But whenever a bullet fired from a gun, its inertia too much produce, or you can say that it's almost impossible to stop the bullet. So why? The reason is that to study about completely about inertia, we need another quantity with the mass, and that is a velocity. So the product of mass and velocity is called momentum. Momentum as a unit is kilogram meter per second, and here. So the student, this was the today our lecture. Hope so you understand that. Thank you.